Hello, I am Chaitanya Kharya, and today we are going to learn about the round robin algorithm for process scheduling. So, the basic of round robin algorithm is that it uses preemption to complete the set of processes that it's given. So, let's start. I am Chaitanya Kharya, and I am E21CSEU0063. So, let's go straight into the main function. So in the start, we are just creating some variables that we're going to use later. Then we're taking in the input as for the time quanta that will be given to us by the user. Then we are taking in the number of processes into the variable n. Now we are setting some arrays that we'll use later, which is the arrival array, which will save the arrival time of each process, each of the n processes. Same for the burst times, the wait time, the turnaround time, and the priority queue that we're going to have, and the temporary burst time. Also, we're creating a Boolean array, which is a complete, which will tell us if the process has completed or not. Uh, so here we're taking the input for the arrival time of the processes. So and the burst time of the processes, it will be saved into the arrival and the burst time, arrays, and also we will set the same values that are in burst array into the temporary burst array, because we will be actually changing the values in the temporary burst array, but at the same time we will be using the burst array to later print the values. So now here we are initializing the complete queue and the priority queue to some default values, so that later we can use them and there is no garbage value in the middle. Okay. Here we are using a while loop to increment the timer. Let's say the first process arrives at 2 seconds. So we'll leave the timer, which we have set to 0 previously, to go up to that 2 seconds so that we can start our further process. So here the timer will increase until it is equal to the arrival time of the first process. And then we will put that first process into the priority queue. Now here we are using a while function, uh, which will run until all the processes burst time is 0. Here in the if loop, we can see that if the temporary burst time is not equal to 0, the flag will be set to false and it will go out of this false for the for loop. If the flag is set to true, it will break out of the while loop. So until and unless all these processes have not completed their burst times, it will not set the flag to true. So that will not break out of this while loop and continue going on. So the main work is happening in this for loop. Here we can see that uh, we are using this to increase the timer, and we are decreasing the temporary burst time of the process that is running at that time by 1, because as the time goes on, the process is also running, but time is decreasing by 1, which is very obvious. Now we are checking if there is a new arrival, a new process that has arrived into the queue. So for that, we have made a function check new arrival. It will uh, check if there is some new process which the arrival time has reached to the timer, like arrival of j is less than equal to timer. So if the timer has reached the arrival time of the next process, it will put it into the queue using this queue updation function. The queue updation function is very simple. It just puts the process into the corresponding index into the queue using this. So going further, if a process is completed, then store its exit time and mark it as completed. If the temporary burst time of a process is 0 and it is not completed, the complete of the value in the complete array for that process is set to false, then we see that we can uh, put the turnaround time. The turnaround time is, how should I put this? The turnaround time is the finishing time at the time at which the process finishes minus the arrival time of that process. So when we put it equal to timer, we are just basically storing the finishing time of that process. And also at the same time, we are setting the index, we are setting the value of incomplete array for that process to true, which means that the process is completed and it will not be later again put it into this if loop because of this condition. So the turnaround time now has the end time of that process after it has finished. Now here we are checking if the CPU is idle or not. So let's say a process arrives at 5 minutes and the a process before that has ended at 4 minutes. So now the CPU is ideal for that time. So this condition is going to check if it is idle or not using the queue and the arrival times and the complete array. It will set the value of idle to true or false accordingly. Now, if idle means that if the value of idle is true, then we will increase the timer and wait for the new arrival to come. Now we are using the queue maintenance function to maintain the entries of process after each preemption in the ready queue. So after each time we use the ready queue, we need to maintain the queue so that it can be used again. Here we are just switching out the values of the priority queue, nothing much happening. Uh, Here we are just putting values into the turnaround time array that we have created, which we have named as turn, and the wait time array that we have created as wait. So earlier we saw that in the turn array, we have put the end times of each of the process. Now, since turnaround time is final time minus the arrival time, so the final time is already in the array, and then we subtract it from the arrival time of that particular process. So we get the actual turnaround time of that process. Similarly, with that wait time, we see that the uh, the total time that it stayed in the in the queue minus the burst time that it had. So that will give us the wait time. Now we're just simply printing out all the output that we have just found. The program number, the arrival time, and the burst time are given to us as inputs, and we have found the wait time and the turnaround time for each of the processes given to us. Using this for loop, we are going to print it out for each process. Now we see that we are just printing out the program number, the arrival value in the arrival array for that particular process, the burst time, the wait time, and the turnaround time. Now here we are finding out the average wait time and the average turnaround time of this whole scheduling that we did. So here we see that we are just summing up all the values in the wait array and storing it in the average wait variable, and similarly for the average turnaround time. Now, when we print it out, we are dividing the total wait time by the number of processes to find the average, similarly with the turnaround time. So, using this algorithm, we just found out the average waiting time and the average turnaround time if we use the round robin process scheduling algorithm. So, thank you very much.